Hello, everybody. My name is Tobias Loger. I'm researcher with the Institute for Housing and Environment in Germany. Together with my co-author and colleague, Guillaume BM, I would like to present to you research work we have done in the framework of the project Mobasi, which is carried out in cooperation with three housing companies, Bauverein AG Darmstadt, Wohnbau Gießen, and Nassauische Heimstätte Wohnstadt in Frankfurt am Main. The work is funded by the German government. The topic of my presentation is target actual comparison and benchmarking used to safeguard low energy consumption in refurbished housing stocks. So what are the challenges we are facing? Half of the 40 million homes in Germany are in multifamily houses. Thereof about 1/3 is owned by housing companies. And most of these multifamily houses are heated by central heating systems, which are operated by the housing companies. So when the housing companies get the energy bill, they just forward the bills to the tenants, which are of course supposed to pay them regardless of the energy standard of the building. So it's just a transit item for the housing companies. However, many housing companies put a lot of effort into energy refurbishment and driven by the challenges of the climate crisis and also to improve the living conditions for their tenants. However, most of them do not systematically track the applied measures and the energy savings. So the idea of the Mobasi project here is to develop a concept for target actual comparison and benchmarking and to apply the concept in cooperation with housing companies. The idea is to attach to processes which are already running in the housing companies and to just add elements which are able to collect and store information about the energy performance of the buildings. So if we take an example building which is not yet refurbished, with an annual energy consumption of about 200 kilowatt hours per square meter and year, so the housing company decides to make an energy refurbishment. The planning is carried out by the housing company itself or by commissioned architects or civil engineers. The new element is now that we store specific information about the energy performance of the building, about the theoretical energy performance, about the thermal envelope, about the heating system in a monitoring database. This enables us to determine the expectation range for the energy consumption. Now, the refurbishment has taken place, the energy consumption is on a new level, and the heat billing is performed as the years before. This is as usual. Now, the new element is that we store the information about the annual energy consumption also in the monitoring database and assign it to the information about the energy state of the building. So now we can compare the metering with the expected range of energy consumption. Usually there will be no problem that will fit, but in some cases there may be an exceedance. And in these cases, we can have a closer look at the operating conditions of the building, maybe also at the user behavior. So we don't have to do this for all the buildings, but only for those where an exceedance has been found. And of course, we can continue this process because the information is stored about the state of the building. We can continue this process in the building stock and also extend it to other buildings which are refurbished. For the collection of the information about the energy performance characteristics of the buildings, energy profile monitoring indicators are used, which are a specific set of query variables and which are indicators on the physical characteristics of a building that have the biggest impact on its energy performance. These indicators can in principle be collected by on-site inspections or by asking building owners. And that's also the reason why these indicators are used or have been used in German energy housing surveys in the years 2009 and 2016. We get a closer look at the form for the building. At the top, we have general information, living space, number of stories. Then we get information about the number of attached buildings, geometrical information, and about the state of heating situation in the attic and in the basement. And we get information about insulation upgrade, thickness of insulation, area fraction, year of installation, and about the window types, the number of panes, the low EQ information about low e-coating, about frames, about the year of installation of the windows. So now that we have gathered the energy profile indicators for all the buildings in the database, a transformation is done to input variables for a physical model. The input variables consist of calculation values and an uncertainty range. Since we are dealing with existing buildings, not all information is available. So we make a treatment of missing information. In these cases where something is missing, we use averages which are valid for the total building stock. And at the same time, we increase the uncertainty, the typical range of this variable. So this is also done for the boundary conditions. Also here we have calculation values and an uncertainty range for the user behavior and for the climatic data. Now we can perform an energy balance calculation with a physical model and get one value for the energy use of the building. And we do a second calculation where we take all these uncertainties of the input parameters and calculate the resulting uncertainty of the energy use. So we get a value for the energy use and we get an uncertainty of this value from our calculation. Now we are coming to the implementation of the concept. As mentioned earlier, we are cooperating with 3 housing companies and they have provided data of buildings in 3 groups, refurbished buildings, ABC, and one group, Group D, with buildings which are not yet refurbished. And so we have got 155 building data sets of building entities, which are mostly apartment blocks, 165 apartment blocks, consisting of more than 3,000 dwellings. Now we have calculated for all the buildings in the database the energy use and can compare it with the meter reading. On the left side, you see a chart where all these values are included. You see here the orange bars, which are meter readings, and you see the blue bars, which are the calculated energy use, and you see also the uncertainty of the calculated energy use. And now we can compare the meter reading with this uncertainty range. These values are sorted according to the ratio of calculated energy consumption and meter reading. At the top, you see here buildings where we have a lower energy consumption than the expectation range. And at the bottom, you see buildings where the measured energy consumption exceeds the expectation range calculated. We see that for most of the buildings here, the energy consumption lies within this expectation range, but for some not. And the idea of the project is now to have a closer look at these buildings because maybe there is something wrong. So now we can have a closer look at the buildings with suspiciously high or suspiciously low energy consumption. And the first steps are to check the building data and the heat billing data and maybe correct the data in the database. And the next step is an on-site inspection of the thermal properties of the building fabric and the heat supply system. And the further step is to examine the operating conditions and the user behavior. In the project, we have already done the step 1 and step 2 and could correct some of the input data to improve the data quality. The next step will be to make these on-site inspections and try to find out why actual energy consumption is higher than expected or lower than expected. Now we can have a look at the coherence of the reality-based physical model and actual consumption. So we make a scatter plot, metered energy consumption by calculated energy use. For example, if we take one point here, we got an energy use calculated 103 kilowatt hours per square meter and year, and we got a metering of 95 kilowatt hours per square meter and year. We now divide the calculated energy use into intervals and have a closer look at these intervals. First of all, we see the number of buildings which are included in the interval. And now we have calculated the average energy consumption for each interval. In this case, we have an average energy consumption of 112 kilowatt hours per square meter and year. And we can also determine the scattering of the consumption, the standard deviation, which is 21 kilowatt hours per square meter and year. This has been repeated for all intervals of the energy of the calculated energy use, and so now we get averages of the energy consumption for each interval. The results are encouraging. As you see, the values are very close to the bisecting line, so there is no strong systematic deviation between the metered energy consumption and the calculated energy use. This is in contrast to findings where an energy performance certificate calculation has been used, where we find curves which are more than that. So the values for the calculated energy use are higher, much higher for unrefurbished buildings than the metered energy consumption. I'm getting to the resume now. We have developed a method for target actual comparison and benchmarking in housing companies, which consists of a monitoring table, including energy profile indicators. We've developed a reality-based physical model where we retrieve missing information and assign uncertainties. We have applied it to a collection of datasets of about 150 apartment blocks and found that the physical model is rather reliable. We have identified buildings with a suspiciously high energy consumption or a suspiciously low energy consumption, and found by checking the data some errors which we corrected. Now this is a better match, but there are still some buildings where the energy consumption is higher than the expectation range. And here we want to go to the buildings, make on-site inspections, and try to improve the operating conditions in the buildings. The perspectives are that we try of course, to extend the database to more buildings, maybe to the whole stocks of the building companies, and to try to reach a continuation on an annual basis of the target actual comparison. That could be part of an energy management in the housing companies. The challenge is, of course, that additional staff would be necessary and that costs money. But however, it could be a contribution to a strategic portfolio management towards carbon neutral housing stocks, including annual determination of annual refurbishment rates and tracking the actual greenhouse gas emission reduction on the way to the carbon neutral housing stock. So many thanks for your attention. I'm ready to answer your questions now.